Hey Rother fam, welcome to it's not a banger, but we're going to talk about groups on the periodic table. So in my journal, I'm going to take the notes this way instead of this way. So if you will, I'm on page 18, the next page in your journal, we're going to title Groups. And on the periodic table, groups are going to be what we call columns. They're going to go up and down. Okay, so we're going to title this Groups. And these are the ones that go up and down, not horizontal. You are about to sketch your first periodic table. Okay, your lines don't have to be perfect, as you'll see with mine. We're going to draw the left side. We're going to draw the bottom of the periodic table. And then we're going to come and draw the right side. All right, I've done this several times. This is the first time for you. So we're going to come one element over, and we're going to go down about an element. And this first element is called hydrogen. We're going to go over an element, and then we're going to go down about two elements. And then we're going to come over this section. We're going to come up about two elements to meet, so these two lines will kind of meet each other. We're going to go over, all the way over, and then we'll come up an element. We'll go over, and this element will be helium. You've just sketched your first periodic table. All right, so these are the columns. So we're going to draw lines. This is group 1. This is group 2. All right, we're going to skip over. This is groups. This section right here are groups 3 through 12. I think it's, yeah, groups 3 through 12. And then we're going to do, let's see, 6 groups here. Let me look. Okay, we're going to call this group 5A. We're going to call this group, no, we're not. We're calling this one, I'm sorry, this one's 3A. 3A. We're going to do 4A, 5A, 6A. I'm running out of room. This is 7A. So that's a 3A, 4A, 5A, 6A, 7A. This will be 8A. All right, what do you think this group is going to be? I skipped it. This is going to be 1A, and this will be 2A. Now, on the periodic table, it also numbers them 1, 2, 3 through 12, 13, 14, 15, 16, 17, and 18. But we're going to look at the numbers with the A on it. All right, so let's make our groups, if you haven't already. All right, everybody get that? Okay, these groups are also called families, okay? So sometimes you will see families. Let's make sure I spell it right. Sometimes you'll see groups called families. And if we are blessed, we have a family we live with. So what we're going to do is over each group, each of these groups, let's put a rooftop. That could indicate a tent, an apartment, a rent house, a mansion. So let's put a roof over these two. And then over here, So I'm of the Rothermel family, and we're all 4 different people, but we behave kind of similarly. We're pretty quiet. We're kind of homebodies. We have different likes and interests, but we're all going to behave somewhat similarly. Okay, so everything under the every element under hydrogen is going to react or behave similarly. Everything under this group will behave similarly, as is these. Now these guys are special. These guys are going to have a castle over their home, and I'll explain why in a minute. So these guys are going to be different from all the other groups. Okay, so let's talk about group 1 here. Okay, I want this one to pop, stand out. So I'm going to take a matte pencil or a highlighter. It doesn't have to be perfect. I just want this to stand out. It's okay. All right, I am going to call this group 1 has a name. These are the alkali metals. And we'll talk in a minute why these are the most reactive metals. So these alkali metals, they have a special name. These are called the alkali metals. These guys right here have a special name. You don't really need to know, but we're going to write in here that this group right here is somewhat reactive. And we're going to come back to talk about that in a minute. So we have the alkali metals, which are the most reactive metals. We have these, group 2, are somewhat reactive. Okay, look at me if you're that far. Okay, thank you. Okay, we're going to skip over these right here. The state usually doesn't test us except to say how many protons do these guys have, how many neutrons, and such. We're going to look at these groups, but these 2 right here have a special name. So I'm going to bring attention to this group. All right, they have a special name called the halogens. Halogens. And we're going to make a note that these are the most reactive. These guys over on this side of the periodic table are nonmetals. Okay, so these are the most reactive nonmetals. All right, so the halogens are the most reactive nonmetals. These guys right here next to them, like group 2, are somewhat reactive. So we're going to write that these guys are somewhat reactive. And then we are going to, these are super special. They have a castle over their house, don't they? I'm going to make that castle green just because. Okay, these guys right here have a name called the noble gases. Okay, so these are the noble gases, and the one thing I want you to know about these guys is that they never
back down, never what?
they never back down, never what? They never react. And sometimes you'll see it called, they are called stable. They don't lose their minds. They never react, or sometimes you'll see them called stable. And I'll kind of show you how these guys react. Okay, look at me if you got that. Okay, thank you. All right, I'm on 9. How many more minutes do I have? I gotta stop by how many? By 14, because I don't want to go over that. Okay, I'll have it. I'll show the whole thing when we're done. Okay, so we're going to look at group 1. All right? Group 1 is going to have 1 valence electron. Okay? Group 2 is going to have 2 valence electrons. So I'll just show you. If we've got hydrogen here, right? Hydrogen has 1 proton in the center. If it's got 1 proton, how many electrons will it have? It's got to have this right here has 1 proton. We've got to balance it out with an electron. So we're going to have 1 valence electron. If we did a Bohr model for all of these elements, they would have 1 valence electron. These guys, if we were going to draw a Bohr model, they would have 2 valence electrons. We're going to skip over here. How many valence electrons do you think they have?
3, 4, 5, 6.
Yes, so we're going to put, you're right, 3, 4, 5, 6, and 7. These guys have 3 valence electrons. These guys have 4 valence electrons.
Oh, yeah.
Like he said, 5 valence electrons. Okay, this one has 6 valence electrons. Can you squeeze a 7th valence electron here? Okay, these guys are going to have a full outer shell. So if we did helium, and we can, helium has 2 protons. If it has 2 protons that are positive, to make the atom neutral, we've got to have 2 electrons. So we're going to put 2 electrons out here. Their shell, this one's outer shell is full, all right? So we're going to do this one right here, neon. Neon has 10 protons, okay? 10 protons. I don't have room for all the shells. How many can fit in the first orbital? Just 2. Well, we're going to have now a second energy level, and it's going to have all 8. We need, so do we have 2, 4, 6, 8? All right. In nature, or on the periodic table, these guys are considered perfect. They're considered perfect because they have a full outer shell, all right? So if you look over at this group, they have 7 valence electrons. How many more do they need to be perfect? They need 1 more. If they had 1 more, they would be like a noble gas. So here's what happens. They're like, hey, dude, if we hook up right here, so if one of these elements hooks up with this element, how many valence electrons would they have together? They would have 8, which would make them like a noble gas. Now these guys right here have 6. They will often pair up with these 2. So if you get 6 and 2, what do you get? 8. So they would be like. So these elements, especially these 4 groups, combine. It's called bonds. They form bonds to be more like these guys, which are perfect. All right. Thank you so much, second period. Right under 14 minutes.